For our next recursively defined structure, we're going to use a full binary tree, which again, I'm hoping you've heard before, but if you haven't, let me know more. A binary tree is going to have at most 2 children. It's a tree, so you're going to have root, you're going to have 2 kids at most. And we use this in our binary search, which you may have talked about before in other classes like data structures, CS1, something of that nature. So a recursive call is quite a jump from this. If T1 and T2 are disjoint full binary trees, there is a full binary tree denoted by T1 times T2, if you want to call it that. It's really merging, consisting of a root R together with the edges connected to the root, to each of the roots of the same left tree or right tree. So here's our base case, our base setup. Step number 1 is that we're going to connect it with to make a full tree. Step number 2 is we're going to be adding more and more subtrees to this. And by the way, something that really bothered me, well, let me take care of the picture first. Notice, and the graphs are helping me out here, that was the original tree, and now I'm adding 2 more items. Notice 2 more items, that's it, to make our next full binary tree. I'm going to put a big fat X on this one if I then were to add 2 more. Notice I'm adding 2 more nodes each time to make a full binary tree. Now, my big problem with this as a programmer is that in reality, we're going to be very structured on exactly how we do this in order. The author kind of made it sound like it could be any order that you want, left or right, and then full. But in reality, most of the time we're going to do it left and then to right and then eventually make it full. You're going to need to ask that when you're doing your application data structures about this. But the author's kind of like, hey, all I'm doing is adding 2 more. Okay, I added 2 more on the left side instead over here. I added 2 more from my original. That makes another full binary tree, I should say. That's how we're making things up. So notice every time, even step 1, added 2 more, great, just made a full binary tree. Added 2 more nodes, great, created another full binary tree. That we can do repeatedly. The next 2, if I was a programmer, would be over here for this next tree because, frankly, again, that makes another full binary tree. So notice that each step connects to another full binary tree or makes it a full binary tree each time we do this recursively.